Hi everybody. This talk is going to be a little bit of a deep dive into how Harvester tracks and manages additional disks. Specifically talking about how we solved this issue, improved non-WWN device operations, for Harvester 1.8.0. A little bit of background first. When we first install Harvester, you choose which disk to install the operating system on, and also which disk to use for Longhorn's default data disk. These things are fixed at installation time, and they can't be changed later. But later though, after installation, Harvester will let you provision any additional disks on any of the hosts in the cluster for use by Longhorn, either the V1 or V2 data engine, or using the LVM provisioner. You can add and remove these disks at any time by going to the host in the Harvester GUI here. This is just a little toy test cluster that I'm running virtualized. We go and edit the config, and then we can go and mess around in the storage tab, and we can see I've got a couple of extra disks here. I've got an NVMe and I've got a dev SDA. So let's go and provision one of them just for fun. So we can see now that's been provisioned for Longhorn V1. And one annoying problem we've had repeatedly in the past is users with additional disks where the disks are visible at the operating system level, but they're not available for provisioning via the Harvester GUI. So in this toy cluster that I've got here, I was able to provision dev SDA via the GUI, but let's look at physically what's present on this system. So if this is the host that I'm on here. It's Harvester 1.7.0, and let's look at the block devices. Name, size, type, label. Here I've got dev VDA. It's a 500 gig disk. That's my operating system disk, which we can see these labels on here. And I've got that's the Longhorn default data partition. But I've also got, we saw in the Harvester GUI that I had dev SDA, and the other one I could select was NVMe 0 and 1. But I've also got dev SDB here. It's a 30 gig disk, and I've got VDB as well, another virtio disk, and they're just not there in the GUI. Why is this so? This is where we go and look under the hood a little bit. So in order for Harvester to keep track of disks in the system, we have a component named Node Disk Manager, and that manages block device custom resources. There's a little bit of a description about that in the README file. A block device is a Kubernetes custom resource that represents a block device on a node. And each block device CR maps to a physical disk in the system and stores some information about the disk, notably whether or not it's been provisioned and what for. So we can go and look at that here. We can go kubectl Longhorn system. We can see the block devices. I've got one called, it's a funny long name, dev SDA, and that's actually been provisioned. That's that one I just set up then. And we've got dev NVMe 0 and 1, which is unprovisioned. And I can even get some more information here. System describe. Can see what's going on with that one, and we can see that we're using the Longhorn V1 provisioner and some events. It added the disk to the node and some physical details about the disk here. What we did originally when we were trying to figure out how to map devices back to block device CRs. I mean, the trivial, one obvious thing to do would be go, oh hey, this disk is dev SDA, so let's just call the block device CR, let's call it SDA. But the problem with that is those names aren't guaranteed to be stable over time. If you physically add or remove disks from the system, what's dev SDA now might be dev SDB later. And so to deal with that problem, we originally went and took the worldwide name of each of the disks and used that, because all disks theoretically should have this unique identifier. And so what we did originally, here's a little bit of code, was if the disk had a WWN, we took the WWN plus some other bits and pieces which actually may or may not exist, and we used that WWN plus the node name and hashed that to make the name of the block device resource, and that was deterministic. This gets a little bit problematic if disks don't have a WWN. They should, but they don't always. virtio disks don't, and we found that disks that are managed by certain types of RAID controller, even if the disk itself has a WWN, that information isn't necessarily propagated through to the operating system, and so we end up not being able to uniquely identify the disk. And I think that's actually what was happening here in this this output here that Vicente has included in this issue, where we've got, it's an NVMe, but it's actually sitting on a SCSI bus, and we never end up seeing ID WWN in this list of output here. Whereas, I mean, we want to. I've got another system here where we've got something that's just an NVMe device, not on a SCSI bus, and we do get the WWN. So anyway, we had a fallback for the case where disks don't have WWNs. We look at its UUID, but that's only there if there's actually a file system on the disk. So there was this workaround where if your disk wasn't identified, go and make a file system on it, and then it'll show up in Harvester. But the problem with that is that works fine for Longhorn V1, where you've got a file system on the disk, but it doesn't work for Longhorn V2, which doesn't have a file system, it's just a block device. Likewise, it doesn't work for LVM, which wants to talk to the whole block device. I did figure out a hack here. There's a workaround, as I explained, to create a file system on the disk, but I figured out a hack with adding some UDEV rules to generate fake WWNs based on the serial number of a disk. And this actually works. That's written up in a knowledge base article. So in the past, if you had disks that you couldn't make a file system on or didn't want to make a file system on, you could apply these UDEV rules and it would generate fake WWNs, which were good enough to make Harvester play nice. And that works, but really we shouldn't have to apply manual workarounds. There had to be a better way of tracking devices. And that's one of the things that we've fixed in Harvester 1.8. So what we've done here with this reworking is we're decoupling block device custom resource name generation from any actual property of the underlying disk. So in fact now block device custom resource names are just randomly generated UUIDs. And so now when Node Disk Manager scans the disks in a system, it will try to identify them and tie them back to block device CRs based on, in order of preference, what's actually on the disk. That is to say, the UUID of either a file system or an LVM volume if present. So that's if a disk has been provisioned, it'll look at what's there and it'll map that back, and it'll look through all of our list of block device CRs and go, is this the one with this UUID? Is it this one? Is it this one? Ah, good, I found it. If it doesn't find it by UUID, it will try to look it up by WWN if present. And if that also fails, it'll look it up by the concatenation of vendor, model, serial number, and bus path altogether. Any of these may or may not be set for given drives. It's a bit weird, but there it is. Bus path will always be there though. So let's look at that in action. If we go back to my 1.7 system and recall those block devices, we could see STA and NVMe in 01. Let's look at the Node Disk Manager logs. It's a nice command there, kubectl n harvester system logs with the app name. Node Disk Manager is starting up and it's detected NVMe, dev NVMe 0N1, and it's detected dev SDA because they've both got WWNs. But then we get to dev SDB and dev VDB and it's going skip adding non-identifiable block device. That's because it didn't have a WWN, nor did it have an FSID, and Node Disk Manager in version 1.7 couldn't work out what to do with it. Now, let's flip over to, I've got a Harvester 1.8 system here, which I've got. So it's Harvester 1.8 RC6. And let's go, I've got the same set of block devices here. And now, if we look at the Node Disk Manager logs, we'll see something a bit different. Node Disk Manager starting up, and we look a little bit further down, scanning device dev NVMe 0 and 1. Hey, we've detected a disk, this bus path, this model, serial, this WWN, and so on. We've found dev SDA, again with the WWN. Here we've also found dev SDB. We don't know what the WWN is, but we don't care because we've at least got the bus path and the model and the serial number. And same with dev VDB. All we've got here is a vendor, but at least we've still got a bus path. The point is we can see the disks now. Dev VDA, the operating system disk, is skipped over because it knows it's the operating system disk and we don't want to expose it through Node Disk Manager. So we can see here that Node Disk Manager is actually seeing all of the devices now. And Longhorn system get the list of block devices, here they all are. And that means that if we flick over to a Harvester 1.8 GUI, and I go to hosts, go in here, edit the config, go to the storage tab, and all the disks on the system are there, and I can provision any of them as I see fit. The other neat thing about this solution, where we've decoupled the names of the block device CRs from any physical property of the disk, is that upgrades just work seamlessly too. The new scanning mechanism that the new version of Node Disk Manager uses, it just works. It doesn't care what the name of the block device resource is, so any existing block devices on an upgraded system that use the old naming scheme will still be detected by Node Disk Manager and will still work just fine. So in summary, if you've got additional disks that weren't appearing in the Harvester GUI, that problem should now be completely gone in version 1.8.0. No need to manually make file system disks. No weird UDEV workarounds. All the disks on each host should just be there ready for you to use right from the start. Thanks for watching, and I hope you enjoy using Harvester version 1.8.